Tonight's curiosity is fueled by the Quick Fix, a coffee cream ale from Bookstore Brewing in Winnipeg. They describe it as a coffee cream ale with a silky feel and a smooth finish with a hops pinch. I was expecting it to be a little bit darker from the description on the can, but so be it. Oh wow, that has a lot of coffee taste to it. I'm going to be up for a while. So what we're doing tonight is taking a look at this. From the wide shot, you might have thought this is an Ethernet switch, but no, this is older. This is an Ethernet hub, which almost nobody uses these days. And it is also 10 base T, another reason that pretty much nobody uses these days. This one was made by CNet Technology, model number CN8020X. Couldn't find very much information about it online, and what I did find was from well over 20 years ago. But what we have is an 18-port hub with crossover built into the 18th port. So if you're linking two together, you'd use this one, because this was before auto MDIX was common, so you had to figure out your own crossovers and stuff. As I mentioned, it's only 10 base T, so there's very little reason to be using something this slow these days. But it did have link lights on all the ports, so that's nice. And in addition to the RJ45 jacks, it also has a BNC for networking and an AUI connection. And again, neither of those are anything that you are going to find on modern equipment, because nobody has used it since the 90s, really. In the mid-80s, though, this was the thing. If you're connecting hubs and routers together, and sometimes even end-user machines, you would run a BNC cable between them with a T-tap like that into the device, and then carry on to the next device, and then a terminator at the end of the line. It was, of course, slow because, like I said, 10 megabits. Also, there was an awful lot of collisions on them, and the hub, like this one here, doesn't do any kind of segregation of traffic at all. It mirrors all the traffic to all the ports. So yeah, there was a lot of collisions, which made it slower than it could be. And that other port on the back is an AUI port, an attachment unit interface, which would typically, but not always, go between transport of some sort and a device like a router or a hub like this. In some larger enterprises and whatnot, they would have leased lines connecting a hub like this to a router back in the head office, wherever that was, or between buildings on a campus or something like that. Or they could also go directly onto data terminal equipment like these fun old serial terminals. It's not quite a serial standard, but it's still a networking standard, but it's a lot closer to to that type of a standard. And there is the spec if you wanted to look it up. But regardless, again, this is something that hasn't been used for decades and decades. But that's enough of that history lesson. What we're really here for is to open it up and see what kind of hardware they were using in these things back in probably the 80s, I would expect, for this device. We'll have to check and see what the components inside are labeled, if they have date codes on them. And I would expect that some of them probably would. Equipment of this vintage tends to be put together with screws, not glue and clips, so at least we should be able to get into it somehow, although I'm sure there is some trickiness going on here somewhere. Let's find out. Why don't you want to come out? What am I missing here? Maybe the rack ears need to come off to disconnect the case? Or maybe those screws are just interfering with something on the inside? I don't know. We shall find out shortly. Now what happens? That really doesn't want to come apart. Ah, there we go. Ah, there's a nice wide clip underneath the front, so I didn't have to take the rack ears off Their screws were just in those notches, so I just had to slide the thing back, and it's probably just stuck on with decades of dust and gunk. So over at this end, we have a self-contained little power supply module with a 2 amp fuse. We'll take a closer look there later. And then we have a little daughter board up here with the LEDs on it. Yeah, just the LEDs. And then a couple of ribbon cables going up to it. Power. These will be magnetics, basically transformers for each of the Ethernet ports on the front. 2 main chips back there, both Davicom DM9081F, and a second one, where are you, over there. And then there's 2 other Davicom chips beside there in the middle as well. And several of these little GTS units here. I'll have to start looking some of this stuff up. I wonder if also if it has a double side on this board or if it's just single sided. Oh yeah, let's look closer again here. 9723, 23rd week of 1997. So that is most likely to be the date of the thing. These guys are also 25th week of 1997, so that dates this thing pretty well. Late 1990s. So I am going to yoink all the boards out of here just to get a closer look at them and see what's going on. This power supply might actually be a useful salvage. It has both a 12 volt and a 5 volt on it, and then ground in the middle. There's the power supply board. Looks like it was bought as a single unit from a third party, which is absolutely fine. A lot of companies do that just so they don't have to get their own design certified. This is 5 volts at 1.5 amps and 12 volts at 0.6 amps. Maybe not the beefiest of power supplies, but probably good enough for a lot of applications. What do we have going on here? We have the fuse, we have a class X2 capacitor, common mode choke, there's 4 diodes down there forming a bridge rectifier, smoothing capacitor, switch mode chip, no doubt, opto isolator down there. There's a couple of diodes on the secondary side of this transformer. Also looks like some inductors, some decent sized capacitors for the secondary side there. Yeah, that looks like a fairly reasonable, fairly standard for the time power supply. And even though it's not a high current power supply, I think it is still a fine piece of salvage. Now let's go into stripping this thing out a little bit further. By pulling those 2 screws, I can get the front panel off, which gives me the LED board. And what's on there, looks like there's a couple of resistor networks, a couple of single inline resistor networks, and it might have a couple of chips that are not there, but there is one chip here. That looks like a Hitachi branding 6C46. It doesn't have an awful lot of the pins connected. It looks like only 1, 2, 3, 4, maybe 5 of the pins are connected, so I don't think it's multiplexing the LEDs, but we have 32 pins there, so that's more than enough for driving 18 LEDs. And then, like I said, just the resistors up there. Right, that's enough of that piece. Let's get this main board out and see what it has to say for itself. Oh, what's going on? Oh, the AUI connector doesn't want to cooperate. I have to take the retaining screws out to get its little... Maybe. It's got this little slide locking thing that locks onto the mating connector, and it's getting in the way. And I could just bend it because I have no interest in repurposing this unit, but we'll try and do this the gentle reversible way, just out of habit if nothing else. There. That's out now. There we go. I will salvage the connector and the switch for later. as those always come in handy. But in the meantime, we have this board here to take a closer look at. Question from before, double-sided board, double-sided silk screen, but no components on the back. So starting down here by the power connector with 12 volts ground, and 5 volts in, and a couple of capacitors, one on each of those buses. We have a couple of LEDs over here. One was power, and what was the other one? COL. No idea. Oh, collisions maybe? Did that indicate data collisions? I guess that would tell you if your network was starting to get congested. Maybe? That'd be a neat feature if that's what it was. Anyway, after that, we have our Ethernet connections on the front and their magnetics, aka transformers. They're even labeled T, T4, all the way up through T22 up there. And these are also transformers here, here, and here, and here. And probably, is that labeled the transformer or is that something else? I'm trying to find it. Oh no, it looks like it's got a U there. Oh yeah, it's got a handful of pins. And one of its pins connects to the center pin of the BNC. Okay. So that is some kind of a transceiver for this. I couldn't find the part number when I looked it up. Of course, a lot of this stuff's going to be obsolete, but maybe some of it's just too obscure. Who knows? Anyway, this AUI, those transformers there are probably isolating some of its lines, I would guess. Let's look at some of these chips a little bit closer, because that's about all that's going on is all these transformers, a bunch of resistors and capacitors, and then these 4 chips, and this lonely guy over here. Myson, never heard of them. MTD392N. Myson Technology Coaxial Transceiver Interface. Oh, okay. So that is talking to the BNC. Sure. ESD protection greater than 2000 volts. Yeah, you definitely want that for something that's running around your facility. And there it is. The coax comes in here. Anyway, equalization, filtering, and transmit and receive data in and out, and an AUI driver with carrier detect. I'm assuming that's carrier detect. Okay. Also collision detect. Oh, collision detection. Okay. Oh, so maybe that is what's driving that LED on the front panel. So let's see what these other guys are. This Davicom DM9081F. And again, there's 2 of these. So I'm going to guess that each of them handles half of the Ethernet ports on the front. And again, there's 18 ports on the front, so these are probably handling 9 each, maybe, question mark? It's an odd number. I would expect 8 and 8 each, but then again, 18 is not a standard number either, you would think. As expected, this is a 10 base T hub controller designed for standards compliant repeaters that incorporate 10 base T transceivers, which is exactly what we've got going on here. Now, there we have the basic block diagram of it. Oh, it's also got a collision LED on it. Okay. And then LEDs for the ports, and an RX and TX for each of the ports on it. And then it's got 2 AUI ports. So I'm wondering if that is what the connection is between these 2 modules and then the other one going to the outside world, possibly. Anyway, and then there's only 8 of them. Okay. TX and RX data ports 0 to port 7. So the way hubs work, and in this case the way repeaters work, which it's talking about, any single network port senses the start of a packet on its receive lines. The chip will broadcast all that received to all of the other network ports. And that is the big difference between a hub and a switch. A hub, all the traffic shows up on all the ports with no discrimination between any of it. It sucks horribly for privacy, but in a secure network environment, well, not a secure network environment, but in a physically locked down network environment where you don't have weird strangers plugging in their computers, you're probably relatively safe, although any one person in the network running something like, I don't know, Wireshark can listen to all the traffic from all the people in the room, which is not ideal from a security standpoint, which is one of the reasons, not the only reason, but one of the reasons why hubs went out of fashion. And then these other two chips, DM9095L, I'm going to guess that they also have AUI ports that are talking to these guys. They probably have a couple of Ethernet ports which are coming up here, and then one of the dual AUI ports on these guys, one of them will probably be going to this through a transformer just to protect it, and the other one will probably be going to this chip which is processing this guy over here, and that would give us all of our ports. Let's see if that's what these guys actually have going on them. DM9095 twisted pair medium attachment. It's allowing Ethernet to connect to AUI. So that's maybe just taking one of the AUI from the other chip and converting it into Ethernet so that then we get 9 and 9, which is our 18. Maybe? Okay. Okay, no, these are providing two outputs. Okay, so there's the AUI on that side. And here is transformers going to the twisted pair, the Ethernet over on this side. Okay. So, but that is one transmit and one receive. Okay, so it's only doing one. So it is taking an AUI from those other chips and creating one extra Ethernet port. Interesting way of going about it. Not sure if that's how I would have done it, or if I would have just gone for a 16-port device instead of an 18-port device and not added these extras. But maybe they just wanted the competitive advantage of having two extra ports than anybody else. Who knows? And other than that, as I said, there's just a whole bunch of resistors and capacitors. Oh, yeah, and there's a 20 megahertz crystal here, which is clocking all four of these guys by the looks of it, as far as I can tell. Again, the traces are bouncing back and forth between vias all over the place to get from one place to another. But as far as I can tell, that is the master clock for everything. I've also noticed, in addition to all the capacitors and resistors that exist, there's also a whole bunch of positions that they could have optionally used more capacitors on just to clean things up and tune things, but it appears that they decided after the fact that they didn't need them. Or perhaps that's for other models, because there are several optional chips which are not included in this particular model here, including one optional RJ45 connector over here which is not used. I'm going to guess that that probably in an alternate universe would have been the uplink, whereas in this one normally you'd use the one with the crossover on it, which I think is that one there. Yeah, and it's even wired to it. And that is about all I have to say about this old guy. Interesting unit for its age. Again, it is definitely a product of a bygone era, because nobody, to my knowledge, uses Ethernet hubs for anything anymore. And unless it's an incredibly legacy installation, nobody's using 10 base T anymore either. But that was fun to take apart, and that can join other things in my recycling scrap. That can go into my salvage bin, along with a few bits and pieces of mechanical stuff. That was fun. Thanks for joining me on that, everybody. Questions and comments, as usual, down below. I will talk to you later.